Good day, everyone. I will discuss to you the Epanet software in designing a water distribution system. So, first, this is my example of simply water distribution system. So, first, you must have a source. By the way, you must change these units into SI units. So, click here, project, then default, then hydraulics, then change it into liters per minute, then okay. So you have a change. Then this auto length of, meaning auto length of is the Epanet did not consider our length in here drawing, but if you change in auto length on, so the Epanet consider the length of pipe based on our drawing. So in reality, if you design the water distribution system in reality, uh, in our case, we use geotagging. Then after we geotag, we input to the Google Earth, and the Google Earth thence provides us the distance uh, of our uh, plan for water distribution system. So, but uh, let us discuss first the simplest term of water distribution system. So you have a source, this one reservoir. So mostly the source in our project is a spring or deep well. So if you tend to spin, so you must add here the total head. So total head meaning the elevation uh, of the source, and also the velocity head. So let's assume that our total head is 150. So the unit of total head is in meters, because in our flow unit is liters per minute. So total head is meters. So next, junction. Junction uh, is where the pipe or the all together. Also, you can put here the elevation and the base demand. So base demand is the demand of the corresponding area that the junction, that the corresponding in the corresponding area. So for example, pila gani diri, so 150. So example na to, the junction here, the elevation of junction diri na. You can click here in browser junction, then 2, and here so 150 yun. Let's say this is 120 elevation, so the base demand in liters per minute, let's say 2200 liters per minute. So next, then 3 junction 3, pila ganito ganina, junction 2 120, junction 3 let's say 100, then the base demand is 2000. So junction 4, let's say elevation is 90, base demand is 2500. Then junction 5, elevation is 80, base demand is 2600. So you have now the corresponding demand and elevation of the junction. So this is example lang to nako. So in reality, the junction is you must use the elevation in reality. So next is the pipes. So input here, the length of the pipe in meters. So let's say it is 1750. Then the diameter is in mm. So for say 400 mm, I think. So for the simplest making, if there is more pipes and junction on more reservoir, you can use Swim or AutoCAD, then import here in Epanet, then click the auto length on to provide the actual length on based on the area. So pipe 1, let's say this is 875, then if 300 ba yun, so 300. So also the roughness coefficient, we use Williams. So in this project also you can select the head loss formula, William or Darcy's William or Cheesy Mannings. So I use William. Then pipe 3, input 450, wrong, 1050, say 300 again. I will check the band medical. So 100, last one, say 550, 200. So we have now the data for this simply water distribution system. So run analysis. So run was successful. So in to determine whether the base demand or the pipes are okay in the water distribution system, so click the table, so select nodes or so nodes here, then the pipe is links. So you will check based on elevation and base demand. So here, so junction 2, you have the base demand that we put on junction 2. Then the pressure head of junction 2 is 9.86, so it is okay. Junction 3 is 38.50. Junction 4, so it is bigger pressure demand, so it is okay, but it is we will decrease it for availability, for sa tawag gani, para mas barato atong pipe. So let's see.